Let's do number one again real quick. It's a parallelogram defined by two vectors. So start by just picking a point and graphing those two vectors. Pick that point, -5, and then +6, and then draw the arrow. 4, 1, and then draw the arrow. Repeat this vector starting at this point, -5, 6. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Draw the arrow and it should look parallel and the same distance. And then we'll just close the parallelogram by completing this line, which is also 4, 1. Now we want to label the points A, B, C, D, but let's be careful to do that. We know that later we're going to have a triangle ABD that's also defined by these two vectors. The only way a triangle can be defined by these two vectors is if this is the triangle. It doesn't matter totally, kind of matters how you put these letters, but you just have to make sure that A, B, and D are part of this triangle with these two vectors. So I'm going to do A, B, C, and then D. So now I've got my triangle with ABD in it. The question is, what's the area of ABCD? Remember, this is the formula for the area of a parallelogram. I might have written it differently because I had to do it from memory. But it doesn't matter as long as it's the first x times the second y, not the first x times the first y. It's the first x times the second y. 1, 2, 1, 2. I might have written it differently this time than last time, but it's okay. Both will work. You'll get the same answer. Just make sure that x1 doesn't go with y1. That's all you gotta do. Make sure to take the absolute value after you're done with it. All right, so for me, x1 is going to be -5, y2 is going to be 1, and so on. And I get 29, which is what we got before. The area of the triangle, which comes up later, will be half of the area of the parallelogram. The next question is about the angles, angle A and angle B, which are these two angles. And because these are parallel lines, doesn't matter if this one's parallel, but because these are parallel, that means that these two angles have to be not equal, but supplementary, which means angle A plus angle B adds up to 180 degrees. They gave us expressions for angle A and an expression for angle B. So I'll replace A with the expression plus the expression equals 180. Solve for x, x equals 8. The next question is, what are the angles in the parallelogram? Meaning, what are these angles? To figure out angle A, we'll take our answer for x and plug it back into the expression for A. So let's see, 8 times 8 plus 1, so that's angle A is 65. Angle B would be 99 plus 2 times 8, 115. The other two angles, let's see, angle A is 65. Well, it doesn't look like 65, but so I guess I didn't number these correctly, which that's not really my fault, but we're just gonna have to roll with it. So angle C is gonna be identical to angle A, and angle B and D are going to be identical. I know I'm glossing over what I'm talking about with that mislabeling the diagram. So I guess this should have been A. And this should have been, I don't know, I have to think about it later. Dang it. So I'm not sure about this AB thing because, my results say that angle A is small and the angle B is big, obtuse. So I would suggest that, this is 115 and this is 65. So it must be some matter of the way I've labeled the graph, labeled my picture. So I semi-randomly just chose A, B, C, D. I could have done A, B, C, D, or I could have started here, A, B, C, D. But they didn't specify where A and B or where any of them go. And where you place them, like if I'd put A up here, then A would have been the smaller angle. And I tried to do different combinations, but I got tired of looking, so I gave up. So ask your teacher about that one. Whether the picture is right or wrong, these are definitely the answers for A and B. And this is still definitely the area for the parallelogram. Yeah, I think they made a mistake in the way they wrote that. They should have said it differently. So I don't think it's possible to make it any different. All right, let's keep going. What are the two vectors that represent the diagonals of A, B, C, D? So in my drawing, and I guess no matter how you draw it, the diagonals will be BD and AC. I'll start with BD, and I could go either direction. I could start here or start here. I'll just start here. And I'll count the x's first. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. And 1, 2, 3, 4, 5 down. So diagonal BD is that, and just repeat the process for AC. Notice the order of the letters matters. If I did choose B, which I did, to be my starting point, when I write the vector, I want to say B first. And for AC, I chose A to be first, didn't have to, but I did. So when I, let's see, AC would be -1, I'm starting here, -1 up 7. So I need to communicate that in my title of the vector AC. If I had chosen CA, it would have been +1, -7. I'm just going to go with that. All right, those are the diagonals. That's the answer to part C. Part D, what's the area of ABD? Of course, it's just half of the area of the parallelogram. Part E, what's the length of the longest altitude ABD? This was the hardest question. They're asking, what's the length of the longest altitude? So this triangle has 3 altitudes. One's right there. That's like probably the shortest one. And since it's an obtuse triangle, the other 2 altitudes are actually outside the triangle. For this base, you'd have to extend it until you get far enough where you can draw a perpendicular that will actually hit the vertex. Let's see, I did. Now for this base, maybe this is the weirdest one, but I need a perpendicular that goes from this base to this vertex. So there's nowhere I can just go straight up from here. I'm gonna have to extend this base. It's gonna be something like that. Okay, so this is the one we're looking for. This one's definitely the longest, and hopefully you remember how we did this before. The formula for the area of a triangle is 1/2 base times height. And usually we know the base and we know the height, and we're always, we're looking for the area. That's the typical problem. But in this one, we already know the area, 29/2. And we're looking for the height, which is the altitude. Now we have to ask ourselves, do we know the base? Not quite yet. This is the base that's associated with that altitude, that height. To figure out this base, we'll have to use Pythagorean. We'll have to make a little imaginary triangle right here. 4 and 1. We'll do Pythagorean. 4 squared plus 1 squared is 17. Let's write that out. That hypotenuse is equal to 4 square root of 4 squared plus 1 squared, which equals √17. So our base is √17. Then we can just plug that in the calculator. It looks like we'll get some either a decimal or we'll get some kind of fraction, 29/√17. And that should be the answer for E. That is the longest altitude. Number 2 is looking for the equation of a circle that circumscribes triangle ABC. We'll start by plotting out ABC. -1, 7 for A, 3, 11 for B, and 3, 1 for C. To find the circumcenter, we need to find the intersection of 2 perpendicular bisectors. To get perpendicular bisectors, you start by finding the midpoint. And I'll definitely choose this one because it's a nice vertical, easy line because it's vertical. This one's harder because it's slanted. All right, midpoint for that one, you can just take the average of the x's, average of the y's. Same thing for this one. average of the x's, average of the y's. So -1 plus 3 divided by 2. -1 plus 3 divided by 2 is 1. And 7 plus 1 divided by 2 is 4. And then to get the perpendicular bisector, you start with that midpoint. Then you have to get the slope of this line, which is -3/2. I just read it from the graph paper, down 3/2. Or you can do the formula y2 minus y1 over x2 minus x1. And then you want to convert the slope, negative reciprocal, to get the perpendicular slope, 2/3. That looks about right, 2/3 slope. So now I have a point, and I've got the slope of the perpendicular. Then I need to just plug in that point into this equation to solve for b. There's some busy work, but see, I get b equals 3 1/3 or 10/3. I'm just going to go with 3 1/3. So I'm going to look at my, I guess it'd be somewhere about like there would be my perpendicular bisector. I just want to make sure that my y-intercept makes sense. 1, 2, 3 1/3. Yeah, that seems believable for a b, for a y-intercept. The equation for this line is just going to be a flat horizontal line, which would be, is it x equals 3? No. Is it y equals 3? No. It's y equals 6 is the equation of that line. All right, so now I have two lines. I didn't write it out. I need to find the intersection. Ooh, should actually be out there. Okay, so I've got my two equations. That's this one. I plugged in the b. And the other equation is y equals 6. So now I have a system of two equations, and I want to find the intersection, so I'll set them equal. 6 on the right side, and then this one on the left side. And that's kind of a booger because it's got fractions in it, but I'm going to do a fancy step. I'm going to multiply the entire equation by 3 to get rid of those denominators. I'm going to multiply everything by 3. And that actually turns out really easy. 2/3 times 3 is just 2x. And notice I switched to 10/3 because I knew I was going to be doing this step, and that's more convenient for me. 10/3 is more convenient than 3 1/3. To convert, you do 3 times 3 plus 1 to get 10/3. All right, then I continue multiplying through by 3. This one just turns into 10. Continue multiplying by 3. 6 turns into 18. So this equation is much easier to deal with than the one with fractions. Subtract 10, divide by 2, x equals 4. All right, so that's just the x coordinate of my intersection point. Normally I plug 4 back into one of the two equations to get y. I'm definitely going to choose this one because there's nothing to do. It's just y equals 6. You could verify it by plugging 4 back into this one. It should also turn into 6, but that's work. So my intersection point and my circumcenter is 4, 6. Let me just eyeball that and see if it makes sense. 1, 2, 3, 4, 6. So yeah, that looks approximately right. It is a little weird that it's outside the triangle, but that can happen. So my circle is going to be something like that. Long problem. All right, we still need to get the equation of the circle. Make sure you reread the directions and make sure you're giving them what they want. They want the equation of the circle. You have to memorize this. This is the general form of the equation of a circle, where h and k are the center and r is the radius. And notice it's squared. The center of the circumcenter and the center of our circle is 4, 6. So 4, 6. I didn't figure out the radius yet. I got to go back and do that. The radius on our circle will be the distance from the circumcenter to any one of the vertices. They all have the same radius. So just choose one. I'm going to choose this one, which was 3, 1. So distance formula between 4, 6 and 3, 1. Do you remember the distance formula? Looks like it's d equals x2 minus x1 squared plus y2 minus y1 squared. So I was plugging those numbers. There's my the center of my circle, and this is one of the vertices from the triangle. So 4 minus 3, 6 minus 1, math, square root of 26. So this is my radius. But to finish off my equation, I don't want, it's not just square root of 26, it's square root of 26 squared. So I'll just leave it as 26. And that's my answer. That's the equation of the circle. Long problem. Let's recap. Equation of the circle that circumscribes the triangle is it's the circumcenter circle. Plot the points, get the perpendicular bisectors, which requires you getting the perpendicular slope and the midpoint, setting the two equations equal to each other, finding the intersection, plugging that into the circle equation, and then calculating the radius, which is the distance from the center to any one of the vertices. 4 is pretty easy. See, vector sums, adding up vectors, w, x. What's the resultant vector of 3x minus w? So I'll make the picture. For w, it was 2, 3, and negative 9, 8. But it's not necessary for this. Yeah, other problems might require us to do it graphically. For example, if I was doing w plus x, I would have to write these head to tail. So I would have to pick up w, like if I was doing w plus x, which I'm not. If I was doing w plus x, I would have to draw w and x so that they're head to tail. This is the head and that's the tail, the beginning and the end, head, tail. So I need to pick this up and put it over here. It's kind of like if you're taking a trip and you decide first I'm going to go here and then I'm going to go there. The net result is just starting here and ending here. And this is the resultant vector. In other words, this is w plus x. But you don't have to do it graphically in this case because they give you numbers. You would just add the two. All right, but this problem, it's not just adding w plus x, it's 3w minus x. So I'll do it numerically. It's 3 times w minus x. Then 3 times w is just 6, 9. So it's kind of like, it'd be, if this is w, then 3w's would be like that. So instead of 2 over, it'd be 6 over. Instead of 3 up, it'd be 9 up. Anyway, 3w is 6, 9, and then you're subtracting x. And I'll just add the two x's. I'll subtract 6 minus 9, 15, 9 minus 8, 1. So this is 3w minus x.